Find the sum or the difference. Remember that you will not be able to use a calculator on the test, so when you're finding the sums or the differences, do the problems without a calculator. Remember that to find sums and differences for fractions, you do need to find a common denominator before you add or subtract. And also remember that you always want to simplify your final answer. Find the product or the quotient. Remember, you will not be able to use a calculator on the test, so do these problems without a calculator. Once again, remember that your final answer needs to be in simplified form. What product is represented by this model? If you look vertically, you'll see that we've divided the whole rectangle into 3 equal pieces, and we're counting one of those 3 pieces. So one of our factors is 1/3. And looking horizontally, you can see that the whole is divided into 4 equal pieces, and we're counting one of those 4 pieces. So our other factor is 1/4, which means we can write the product as either 1/3 times 1/4, or we could write it as 1/4 times 1/3. Draw a chip model or a charged field model for each of these number sentences. So -1 plus -3 is an addition problem. We're going to add 1 negative chip and 3 negative chips to the field, which will give us 4 negative chips. So our sum is -4. This one is a subtraction problem. So we're starting with 1 negative chip in the field, and then we want to subtract 3 positive chips. Since we don't have 3 positive chips in the field, we add 3 zero-sum pairs to the field, and then we take away from the field the 3 positive chips, leaving us with 4 negative chips. And for this one, it's an addition problem, so we add 4 positive chips and 3 negative chips to the field, and we notice that we have 3 zero-sum pairs in the field. So we're showing those zero-sum pairs being eliminated by putting x's through them, and that leaves us with 1 positive chip, which is a sum of 1. Name the integer number sentence that is represented by each of these models. So the first one is an addition model. We know that because we can see that the 2 add-ins are lined up in each column, and there were some zero-sum pairs that resulted. So the first of our add-ins is 2. That's coming from the 2 positive chips. And the second add-in was -4. That's the 4 negative chips we see in the second column. That resulted in 2 zero-sum pairs, and that left us with 2 negative chips. So that gives us a sum of -2. For the second one, we can see that we're taking something away, so it's a subtraction problem. We started with 4 negative chips, and then we took away 2 negative chips, and we ended up with 2 negative chips. So -4, that's the 4 negative chips we started with, minus, because we're taking away, -2 because we're taking away 2 negative chips, and then that leaves us with a difference of -2. And for the third one, we can also see that it's subtraction. We're taking away 2 negative chips, and what we started with was that 1 negative chip that we see on the left. In order to take away the 2 negative chips, we had to add one more plus minus pair into the field, one more zero-sum pair, and that left us with 1 positive chip. So we started with 1 negative chip, that's the -1. We took away 2 negative chips, that's the -2, and that left us with 1 positive chip. Draw a partition model to illustrate the division problem 1 1/3 divided by 1/6. Then explain how to use the model to find the quotient. To draw the model, we first have to start by illustrating 1 1/3. So we have one whole, and then another whole divided into 3 equal parts, and we're going to show one of those 3 equal parts. So we now have 1 1/3. To divide that by 1/6, we need to take our model and show pieces that are a size of 1/6. So for this one, we'll just subdivide again into 6 equal pieces, and we need to do the same thing with the whole. So this is our model that illustrates 1 1/3 divided by 1/6. Now let's explain how to use it. So in order to use this, we have to count the number of pieces that are the size of 1/6, which are in 1 1/3. So if we count those pieces, we'll see that we have 8 pieces. So to use the model, we have to say that since there are 8 pieces, the quotient must be 8. There are 8 pieces that are the size of 1/6 inside our 1 1/3. Now we could also find the quotient without using a model by simply dividing 1 1/3 by 1/6, and we'll also have a quotient of 8. Find one rational number between 3/7 and 4/9. Now there's more than one solution to this, but every answer that we have is correct will be a number between these two numbers. The first thing I'm going to do is find a common denominator between the two fractions. So the least common denominator is 63. So the equivalent fractions to these two that we started with are 27/63 and 28/63. Now since there is not a whole number between 27 and 28, we're going to have to write another pair of equivalent fractions so that we can try to find a whole number numerator between our two fractions. So I'm going to simply find another denominator by multiplying each of the fractions by 2/2. And I'll have the equivalent fractions 54 126, that's equivalent to 3/7, and 56 126 is equivalent to 4/9. Since there is a whole number between 54 and 56, I can say that 55, which is between 54 and 56, 55 126 is between 3/7 and 4/9. Remember, it's not the only correct answer, but it is an answer that is exactly halfway between those two numbers. For the letters in the word luckiest, find the ratio of consonants to vowels and the ratio of vowels to total letters. There's 3 ways we can write the ratio of consonants to vowels. The consonants in the word are L, C, K, S, and T, so there's 5 of them. And the vowels are U, I, and E, so there's 3 vowels. So we could write a fraction, 5/3. We could also write 5/3, or we could use the colon notation, which also means 5/3. For vowels to total letters, the number of vowels is 3 and the number of total letters is 8. So we also have 3 ways that we could write this answer. Solve the proportion 3/7 equals 7/x. If we cross multiply and solve, we have x equals 49/3, which we could also write as 16 1/3. A car rental company rents passenger vans and vans. For every 28 cars in the rental company's fleet, there are 21 vans. If the company has 60 vans in its fleet, how many total vehicles, the total of the cars and the vans, are in the fleet? The ratio of cars to vans is 28 to 21, and we know there are 60 vans in the fleet, so we can use that to find the number of cars in the fleet. So if there's 60 vans, there have to be 80 cars. But we're asked how many total vehicles there are, the total of the cars and the vans. So there's 60 vans and there's 80 cars, so the total vehicles is 140. Pam has 19 yards of fabric. She needs to cut the fabric into pieces which are 1 1/3 yards long. What is the total number of whole pieces she can cut? And if she cuts as many whole pieces as possible, how many yards of fabric will she have left over? So for the number of whole pieces, we're going to take the 19 yards and divide it into pieces that are 1 1/3 yards long, which would give us a quotient of 14 1/4. The number of whole pieces she can cut is then 14 whole pieces. The 1/4 is 1/4 of a piece that she has left over, which we're going to use for part B of our question. If she has 1/4 of a piece left over, that means she has 1/4 of that 1 1/3 yards that makes up each piece, which means she has 1/3 of a yard of fabric left over.